Hi, so welcome to the another class of Internet of Things. So in this class of IoT, we will study about optimizing LTE Advanced for your MTC. So where your MTC here refers to machine type communication. So in this class, we will study that how LTE Advanced can be optimized, can be utilized for your machine type communication, and how then it enables the Internet of Things or our Internet of Everythings here. So as we know that the cellular systems like our 3G systems, our GSM, our 4G LTE and the upcoming fifth generation of the cellular technology can act as a key player in enabling the Internet of Things and our machine type communication. That means each machine is communicating to another machine here. So there are certain factors here which makes these techniques suitable for your MTC, for your machine type communications. Now we know that LT, your long-term evolution, which is your fourth generation of cellular technology, is expanding new frontiers. That means it is evolving and acting as a new basis for this Internet of Things here. So now when we have to enable this technology, that means when we have to utilize this technology for smaller devices, so what we are trying to do, we're trying to develop here a new infrastructure, but utilizing by harnessing an existing one. We will be deploying the IoT here, but with the help of the existing systems like your GSM systems, like your 4G systems here. So that means the first criteria for optimizing this LTE Advanced for MTC is that using all kind of spectrums, using all spectrums. Now, for our machine type communications and IoT, we know that the ISM band is utilized. That means like 868 megahertz, your 915 megahertz, then your 2.4 gigahertz to your 5 gigahertz. So that means we have to expand here the capability of LTE towards this unlicensed spectrum, because our LTE or our cellular technologies harness the licensed spectrum here. So as the LTE here is expanding or evolving towards the new frontiers, so that means it has to use all kind of spectrums. That means we have to extend LTE advanced to these unlicensed spectrums. Now we have studied here that if we have to deploy the IoT, how it can be coexisting with your existing systems like your GSM and your LT. So that means we have the deployment in GSM subcarriers and deployment on your LT guard bands here. So that means this is the first factor here, that it is being optimized here for your machine type, for your small type communication. Now another thing which is that LT direct is always on the proximity awareness, because we are always using like proximity sensors which are gathering the real time information here from the environment. Then with the help of these sensors we have certain gateways and then the cloud and internet connectivity to store the various data which is collected there. So with the help of such factors, we are optimizing here the LT for your machine type communication. So this LT optimization or this optimizing LT advanced here for MTC is basically a part of your the 3GPP standard, the release 13, which is the global 3GPP standard. So this LT advanced is an important feature of that. Now, you're optimizing the systems. Now, what are the various benefits that will be we are retrieving here for this machine type communications? So, those various factors here which account for this. Now, your LT system here provides reliability, efficiency, and longevity. Three factors that it provides me with: reliability, Second one is the efficiency, and then the longevity of this system. So that means these are the benefits of 4G LTE which will be harnessed for your machine type communication here. Now, another is that we will have a significant increase in the battery life. Now, we will be using various kind of devices. So, we need devices which has more battery life. So, what we have that we have increased battery life here for devices which is achieved here with certain techniques which we will study here. Next thing, that reducing the cost. Cost is an important factor here. So we are reducing the cost and also reducing the complexity, and simultaneously with that we are enhancing the coverage. Now we have studied that we are enhancing this coverage up to 20 dB in our GSM systems which are used for this IoT, and the narrowband LTE which is also increasing here the coverage. Now another factor is that we have provided the coexistence of this machine to machine communication with the broadband services. We have certain broadband services here. So these machine to machine communications can be deployed with these services. So we can say that the system, this your LTE Advanced here, plays a key role in the multiple solutions which are required to connect the Internet of everything. So your 3G systems and your 4G LTE systems here serves as wireless wide area network for your Internet of Things here. So that means it will provide here machine to machine type services like remote monitoring, the remote controlling, and automation and other OTT management services with the help of this optimized LTE for your machine type communication. Now, the certain important factors which makes this a more reliable technique. So, first one of them is the LTE-MTC, that is your long-term evolution for machine type communication, significantly increases the battery life. So the first factor is that we have an increased battery life here. Now this battery life here is increased with three sub factors. First one of them is your PSM, which is your enhanced power saving mode. So the first one is my PSM, which is my enhanced power saving mode. Now that means the system has more efficient techniques to turn on and off the modem. That means every time we don't have to keep the modem on. So that will naturally here increase the battery life, because that can be turned on, or then it could be switched off here for the according to the requirements of the transmissions. Because what we require here in your Internet of Things, that we require infrequent transmission of data, and that is bursty and small packets of your data. So it provides here optimized solutions for your scheduled transmissions or your scheduled applications here. Now, after enhanced power saving mode, the next sub-factor which I have is extended discontinuous transmission. Next one which I have here is my extended discontinuous transmission. So that means we have in earlier discontinuous transmission only, but now we have the extended discontinuous transmission here. That means we have longer sleep cycles which are optimized for delay tolerant applications. That means we have longer sleep cycles here for your discontinuous transmissions. That means if we don't want to transmit, if there is nothing to transmit there, so the device can go here to the sleep mode for longer time here. Third one is the next sub-factor which I have here is connectionless random access channel. That is connectionless random access channel here. So that means the data transmission here is done on this common channel. This is a common control channel. So that this is used here for data transmission, making it more efficient transition of the data. So these are certain optimizing for the LTE advanced for your machine type communication systems. And other factor which we have here for this is less frequent tracking area updates and measurement. Now, if we have less tracking area updates, so that means it reduces the signaling, and the system here is configurable for your low to zero mobility applications, because some of the applications will have low mobility and some of the applications will here have high mobility or a medium mobility. So we have less tracking area updates here for this MTC scenario. Now, one of the factors which I would like to discuss here, that is a power saving mode, which is a very crucial factor here. My power saving mode here. So I have one case here in which I will have my without LT MTC. This is my without LT MTC, and the next which I'll draw here is with LT MTC here. So now I have this on this axis the model power consumption. Similarly, I will write here MPC, model power consumption, and this is my time axis. Now I will have here M to M, that is my machine to machine transmission and reception here. So I will have a setup also here. That means this is the stage here where my device will be in off state. So in this without LT, I will have a case here for setup and registration. This is my without LT MTC. I'll explain both. Now, in my with LT systems or with LT MTC, I will also have this machine to machine transmission and this reception here. So I will have, instead of this setup, I will have simply the service request here, and then I will have here my power saving mode. The device is not off. This is here in the power saving mode. So instead of the setup and connection registration, what I have efficient modem wake up. So in this system, the first one, which is my without LTE MTC, the device requires signaling. It requires signaling before setting the data or transmitting the data. Now, why it requires signaling? Because before that, it needs to register to the network. Every time it will go to the off state, and every time when again it will have to send the data, it will have to register to the network. So that means it increases the signaling here. Now, in this case with my LTE MTC, I have my power saving mode. That means the device always remains registered to the network, but it has the capability of efficient modem wake up. That whenever it requires to transmit the data, only this modem is required to be waked up. Every time you don't have to register to the network, so that means it reduces here the signaling load. So this is how your this LTE-MTC system here is a better solution or a better approach for your machine type communications here. Now after that, the next factor that how it proves to be a better approach is that now this LTE-MTC enables a simplified structure here, because we require small packets of data to be transmitted, and which are also infrequent in our in the nature. That means not a continuous transmission here. So in our regular LTE advanced systems, if we had the wide band for transmission, so we have using this for MTC the narrow band, because we have narrow band deployment in your GSM subcarriers, also in your LTE guard band also. Now, the earlier systems or these big systems have, if your fast data rates, so this system will have your reduced data rates, because we have infrequent data transmission. Now, in the cellular systems, we have diversity antennas. We have diversity antennas, and here we have only single reception antenna. I have single reception antenna here. Now here I will have FDD or TDD operation. But for my LTE MTC, what I will have half duplex operation here. I will have my half duplex operation here. So these are the factors which makes this better approach here for your Internet of Things and for your machine type communications. Now another factor is that it provides us an enhanced coverage. We have studied that in our narrowband GSM also, and in our narrowband LTE, that it provides enhanced coverage here. So enhanced coverage, that means it have redundant uplink and downlink transmission. Redundant uplink and downlink transmission, and that means another factor is that we have single frequency network multicast. We have single frequency network multicast. So what does it mean? It means that same broadcast signal is received from two cells. If I have one cell here and another cell here, like this, and this is the device, so this is single frequency network multicast, it will be receiving the same signal here from both of the cells. So coverage is increased and the strength of the signal is also improved simultaneously. So these are here some of the factors which makes this MTC a better approach, because it is being also used with the existing infrastructure, because we don't want to deploy some another system. We just want to harness the existing system and deploy this new technology with that system. So this LTE-MTC also coexists with your broadband system. So we also know that we have multiple narrowband regions in our like GSM, in UMTS or LTE systems, which provide the scalable resource allocation for these devices. So here in this class for optimizing the LTE advanced for MTC, we just have covered that what are the various vector and how this LTE advanced is optimized for your machine type communications and how it enables the Internet of Things. What are the features like your deployment in your narrow bands, that means in your guard bands or in your sub carriers, then introducing the power saving mode, then enhancing the coverage here. So this is all here for today's class. Thank you so much.